Bismillahirrahmanirrahim. Exercise 7.1, question number 15. Prove that the line segment joining the midpoints of the sides of a quadrilateral taken in order from a parallelogram. So we start the proof. We simply consider any random quadrilateral A, B, C, D. The position vector of A is small a, of B is small b, of C is small c, and of D is small d. Let's start writing our proof. Consider a quadrilateral A, B, C, D. Position vectors are all mentioned on the figure. So let P be the midpoint of AB. So the position vector of point P will become A plus D divided by 2. We may write it as point P has got position vector A plus D by 2. Now Q is the midpoint of AB. Q be the midpoint of AB. So point Q has got position vector A plus B divided by 2. A plus B divided by 2. R be the position vector, R be the midpoint of BC. So I get point R has position vector B plus C by 2. B plus C by 2. And S is the midpoint of CD. S be the midpoint of CD. So the point S has got position vector C plus D by 2. C plus D by 2. Now let's evaluate the vector PQ. PQ. It becomes position vector of Q minus position vector of P. Position vector of Q is A plus B by 2 minus position vector of P is A plus D by 2. So it simply becomes A plus B minus A minus D whole by 2. And you can see that A got cancelled and we have the vector PQ as B minus D by 2. Let's find the position vector SR. Let's find the vector SR, not the position vector, simply the vector SR. Vector SR becomes the position vector of R minus position vector of S. Position vector of R is B plus C by 2. Position vector of S is C plus D by 2. So we get B plus C minus D whole by 2. It becomes C got cancelled and I have B minus D by 2. Let's evaluate the vector SP. The vector SP is equal to position vector of P minus position vector of S. Position vector of P is A plus D by 2 minus position vector of S is C plus D by 2. So I get A plus D minus C minus D whole by 2. As a result, D got cancelled and I have A minus C by 2. Let's evaluate the vector RQ. RQ is equal to position vector of Q minus position vector of R. Position vector of Q, A plus B by 2. Position vector of R, B plus C by 2. Result is A plus B minus C whole divided by 2. As a result, B got cancelled and I have A minus C by 2. Let's compare these results. What do we observe? That PQ is equal to SR. This tells us that PQ is equal to SR and SP is equal to RQ. SP is equal to RQ. Hence, PQ is equal to SR, SP is equal to RQ. Hence, PQRS is a parallelogram because opposite sides are parallel and equal. So the result is proved.